Hello and welcome to today's class on stoichiometry. Now we have some formulas here and I would like us to memorize these formulas because it is going to help us to solve at least 50% of questions in stoichiometry. So the formulas are: N stands for number of mole. Number of mole is equals to mass in gram over molar mass. Mass in gram over molar mass. Then number of moles is also equal to number of particles. Now when we talk about number of particles, we refer to number of atoms, molecules, and ions. So if you have been asked question or you see questions that says how many atoms are present or calculate the number of molecules, it is talking about what? Number of particles. So number of particles over Avogadro's constant. Now Avogadro's constant is 6.02 times 10 raised to power 23. It is actually a value. Okay, then number of moles is still equal to concentration in mole per dm cube. Now this is what we refer to as molar concentration. Molar concentration. Molar concentration is measured in mole per dm cube. So number of mole is equals to concentration, that is molar concentration, because we also have what we call mass concentration. Mass concentration is measured in gram per dm cube. All right, so number of moles is equals to concentration in mole per dm cube times volume in dm cube. Again, number of moles is also equal to volume at STP. Volume at STP over 22.4 dm cube. Now, your volume, whatever volume you are using here, must tally with the units that you were given here, which is dm cube or liters, as the case may be. So, if you were given the question in cm cube, you're going to convert. All right. So, having known this, let's go straight to the questions. So, looking at this question, 56 cm cube of a gas at STP weighed 0.11 gram. What is the vapor density of the gas? So, we are going to first of all write out our parameters. So, what are the parameters here? We have 56 cm cube of a gas and then we have our mass. So, the first thing to do is to find the number of moles. So, this is volume at STP. So, we're going to find the number of moles. To find the number of mole is equals to volume at STP over 22.4 dm cube. All right, so this is dm cube, but this is cm cube. So we are going to convert this cm cube to dm cube. So to do that, that will be 56 divided by 1000, and that will give us 0.056 dm cube. So we can now solve. So number of mole is equal to volume at STP over 22.4. So this is equal to, the volume now is in dm cube, 0.056 over 22.4 dm cube. So we are going to press our calculator and that will be 0.056 divided by 22.4, and number of mole will give us 0.0025 moles. So we've been able to get our number of moles now, but that's not what we are asked to find. So having gotten our number of mole, we're going to find our molar mass. So from here you can see that number of mole is equals to mass in gram over molar mass. So number of mole is equals to mass in gram over molar mass. Now we have our number of mole to be 0.0025 is equals to, our mass in gram is 0.11 all over molar mass. So we're going to cross multiply. We have that 0.0025 mole mass is equals to 0.1. So we're going to divide both sides by 0.025. So divide by 0.025. And what do we have? This cancel, this cancel. So let's press our calculator. we have that 0.11 divided by 0.0025, and that will give us 44. So this is our molar mass. So M is equal to 44. So we have our molar mass to be 44. So we have that vapor density is equal to molecular mass or molar mass divided by 2. So this will be 44 divided by 2, and that will give us what? 22. So our vapor density is 22. So this is the answer to this question. Now, some students can find this method long and tedious, but there is a shortcut to solving the question. Having had your cm cube here, your volume at STP, you have this, you have your mass, which is 0.11 gram. You are looking for molar mass. So you can actually equate this to this and get your molar mass. Then upon getting your molar mass, vapor density is equal to molecular mass over 2. With this, you can now have your vapor density. Let's solve. So this is now, we are equating this to this. So our mass in gram is 0.11 over, we are looking for molar mass, is equal to volume at STP is giving us this. So we've already converted it to dm cube, and that will give us 0.056 divided by 22.4. So when you cross multiply, you are going to have that 0.11 times 22.4 divided by 0.056. So let's press our calculator. 22.4 divided by 0.056, and that's going to give us 44. So our molar mass here is 44. Then, in order to find our vapor density, because the question says what is the vapor density, in order to find the vapor density, you have that vapor density is equal to molar mass, molecular mass divided by 2. So with this, 42 divided by 2, you have your 22 as your answer. Isn't that simple? So let's look at another question on stoichiometry. Now the question says sodium reacts with chlorine gas to form sodium chloride according to this equation. If 4.6 grams of sodium is used, calculate the mass of chlorine gas needed for complete reaction. So what will be the mass of chlorine gas? We're looking for mass. Now what's the unit of mass? The unit of mass is gram. Alright, so looking at this, we have our mass of sodium and we have our relative atomic mass of sodium here. So in order to find the number of mole, we are going to equate number of mole is equals to mass in gram over molar mass. Alright, so number of moles of sodium. So this is a number of moles of sodium. Number of moles of sodium, you have it to be mass in gram over molar mass. So mass in gram is 4.6 divided by molar mass. Molar mass of sodium is 23. Are we together? So let's press our calculator to divide this. So we have that 4.6 divided by 23 will give us 0.2 moles of sodium. So this is the moles of sodium. Now from this reaction, you can see that 2 moles of sodium was needed to produce 1 mole of chlorine. So 2 moles of sodium gave us 1 mole of chlorine gas. Are we there? So 0.2 moles of sodium will now give us 0.2 times 1 divided by 2. So this times this divided by this. So you have that 0.2 divided by 2, that will give us 0.1 mole of chlorine gas. Now this is the mole of chlorine gas that was used according to this equation. But the question says that we should find the mass of chlorine gas. So finding the mass of chlorine gas will take us back to this equation. Number of mole is equal to mass in gram over molar mass. So here we are now looking for the mass in gram. So the molar mass we already have is 0.1 is equal to mass in gram. That's what we are looking for over molar mass. So what's the molar mass of chlorine? Chlorine is 2 times 35.5. So we press our calculator. 2 times 35.5, and that will give us 71. So you have 71. So cross multiply, you have that m is equals to 0.1 times 71. So times 0.1. So that will give us 7.1 gram of chlorine is needed. Okay, again, if you find this process tedious or hard for you, all you need to do is, looking at the equation for the reaction, you can solve it straightforward from here. So all you need to do is, this is 2 moles of sodium. So 2 moles of sodium gave us 1 mole of chlorine. 2 times the molar mass of sodium is what? 23. 2 times 23 will give us chlorine. 2 times 35.5, that will give us 71 gram. So this times this will give us 46 gram is equals to 71 gram. So coming here, 46 gram is equal to 71 gram. Therefore, from what we have here, 4.6 gram will now give us what? Will give us 4.6 times 71 all over 46. When you solve it, it's going to give us 7.1 gram. So which method do you think is easier? The first one or the second one? Tell me in the comment section. Okay, so let's look at another question. Calculate the molarity of a solution 5.85 gram of sodium chloride in 500 milliliter of solution. All right. So the first thing to do is to find our number of moles. So to find the number of moles, we have that mass in gram over molar mass. Our mass in gram is what? 5.85 over molar mass. Molar mass of sodium chloride, let's calculate. Sodium is 23 plus chlorine is 35.5. So let's add up. 23 plus 35.5, that will give us 58.5. So you have that molar mass here is 58.5. So dividing, you have that 5.85 divided by 58.5, that will give us 0.1 mole. That will give us 0.1 mole. All right. So with this, we have been able to calculate our number of mole. But the question says, what is the molarity? So what is the formula for molarity? Molarity is moles of solutes over volume of solvents in dm cube. Volume of solvents in dm cube or liter. So this is molarity, moles of solutes over volume of solvents in dm cube or milliliter. So what's the moles of solutes we have? Now we have the moles of solutes to be 0.1 divided by volume. What's our volume? Our volume is in milliliter. So we're going to convert by dividing by 1000. In order to convert it to what? Liter. It must be in liter or in dm cube. So dividing this 1, 2, 3. So this will give us 0.5 liters. So 0.1 divided by 0.5. 0.1 divided by 0.5. You have it to be what? 0.2 molarity. Answer. Isn't that simple? Okay, so let's look at another question. What is the molarity of a solution containing 4.9 gram of tetraethyl sulfate 6 in 250 milliliter of solution? Okay, so what is the first thing to do? We are going to find the number of moles. So finding the number of moles is equal to mass in gram over molar mass. So what is our mass in gram here? Our mass in gram is 4.9 divided by the molar mass. So what is the molar mass of tetrazoyl sulfate 6? So you have tetrazoyl sulfate 6. This will be 2 times 1 plus sulfur is what? 32 plus oxygen is 4 times 16. So you have that 2 plus 32 plus this times this will give us 64. Yeah. So we're going to add up. Add up. You have that 64 plus 32 plus 2 will give us 98. So this is our molar mass, 98 gram per dm cube. Okay, so we have this to be 98. So dividing, you have 4.9 divided by 98. That will give us 0.05 moles. All right. So having gotten our moles, the question says what is the molarity? So let's look for molarity. Molarity is moles of solute over volume. Now the volume must be in dm cube or in liters. It must be in dm cube or in liters. So what's the moles of solute? The moles of solute we have here is 0.05 over the volume we have here is 250 milliliter. So this is in milliliter. We are going to convert this milliliter to liters by dividing by 1000. So this will give us 1, 2, 3. So this will give us 0.025 liter. So 0.025. So we're going to press our calculator. 0.05 divided by 0.025. That will give us 2 molarity. Answer. Now, in case you find this method very hard, there is a simple way to solving it. So all you need to do is, you have been given your mass, you can find your molar mass, then you are going to equate this to this, because this is a mole per dm cube, which is equivalent to molarity. Yes. And then this is what? Volume. So you can equate this. Once you see questions on molarity, you can simply equate this to this and get your answer. So you have your mass, you have your molar mass. You are looking for the concentration in mole per dm cube. That is the molarity here. You are looking for concentration in mole per dm cube. That is molarity. Then you have your volume. This volume, you must convert this volume to liters. So let's solve so that we'll see if we can arrive at the same answer. So to solve, you have masses 4.9 over molar mass of tetrazoyl sulfate 6 is 98 is equal to concentration in mole per dm cube, or molarity is what we are looking for, times volume. Volume is 250. Then if we convert it to dm cube to liters, it will give us this 0.025. So you have that. Let's press our calculator. You have that 4.9 divided by 98 will give us 0.05. 0.05 is equals to 0.025 C. So divide both sides by 0.025. Divided by 0.025, you have your answer to be 2. Your concentration to be 2 molarity. Answer. Isn't that simple? Okay, so let's look at this question. Calculate the number of atoms present in 2.7 gram of aluminium. All right, so we are asked to find the number of atoms. So once you hear find the number of atoms, molecules, or ion, that means you are asked to calculate the number of particles. And you're going to equate this to this. So the first thing to do is to find the number of moles. Number of moles is equals to mass in gram over molar mass. So mass in gram is 2.7 over molar mass. Molar mass of aluminium is 27. So we press our calculator. 2.7 divided by 27. We have to be 0.1 mole. But the question says the number of atoms. So having gotten the number of mole, our number of mole here, we can now equate this number of mole to number of particles is equal to Avogadro's constants. So number of mole is equal to number of particles over Avogadro's constants. So this will be number of mole will be 0.1 is equals to number of particles is what we are looking for. That is the number of atoms all over Avogadro's constant is 6.02 times 10 raised to power 23. This is actually a constant. All right, so we are going to cross multiply, and number of particles will give us 0.1 times 6.02 times 10 raised to power 23. So number of particles is equal to, let's press our calculator, 0.02. So this is going to give us 6.02 times 10 raised to power 22 atoms. Oh, but this process is hard. I have another process for you. Okay, so simply, all you need to do is simply note that mass in gram over molar mass, you can equate it to number of particles over Avogadro's constants. Are we together? So instead of solving it 1, 1, 1, 1 like I did here, you can just say this is equal to this, and then you cross multiply and do your solving. So let's solve. Mass in gram, the mass in gram given here is 2.7. Our molar mass of aluminium is 27. Then the number of particles is what we are looking for, over 6.02 times 10 raised to power 23. This is a constant. So you're going to cross multiply. You have that number of particles is equal to 6.02 times 10 raised to power 23 all over, 6.02 times 10 raised to power 23 times 2.7 all over 27. Now, if you do your solving here, you're going to arrive at 6.02 times 10 raised to power 22 atoms. So which process is easier for you? I'd like to know in the comment section. Okay, I would like you to solve this. I'd like you to solve this. Assume this is now 1.7 and this is no longer aluminium. You now have sodium. This is no longer aluminium, you have sodium. And this is now sodium is 23. So what will be your answer? Calculate the number of atoms present in 1.7 gram of sodium. Sodium is this. Let me have your answer in the comment section. Thank you for watching. Bye.